All right. So for today, we're gonna be focused more on our first step in data science. So that is for us to learn how to scrape the web. So where is it? Mm, All right. So um, yeah, today is our fourth session. So we're gonna be focusing mainly on web scraping, and then um by next week, we'll be focusing on Python pandas. Let's see. Just to make sure, recursive functions. Oh yeah, so we haven't actually finished that one yet. So recursive functions. So okay, so let's start here, and then we're actually halfway through this PowerPoint. So I guess about 1.5 hours or 2 hours for this part, and then the remaining time will be for um web scraping. Okay. All right. So, recursive functions actually, it's kind of like the same thing that we've discussed before about breaking down problems into simpler problems. And the only difference is that recursive functions use the same function over and over again until an answer is reached. Um, but it's not always like this. There are cases where you can use two functions, but both of them are going to be used over and over again. So it's kind of the same thing. So that's what we're gonna explore here. So of course, the design strategy is called recursive design, and the functions that result from that are called recursive functions. Okay. So again, a recursive function is a function that calls itself. While if you think about it, it's relatively simple, but it's actually a bit difficult to actually make one, especially for complex problems. So from what we can read here, it examines the base case to determine whether to stop or to continue with another recursive step. In other words, you need to first determine when the recursion work will end, because if you can't really determine when it will end, then it's just equivalent to a infinite loop, and it's gonna consume too much memory and until eventually it will crash. So that's not something that you want. So you have to first evaluate a base case or an exit condition in order for you to make an effective recursive function. Okay. Now here, basically it's just this one, right? We're gonna convert this into a recursive function. Now it's using the while loop, lower is less than or equal to upper. And then while, right, while this loop keeps on going over and over again, we are increasing the value of lower by 1. So eventually it will reach a point where lower is greater than upper. Okay. So that is the exit condition. This is the base case when um the moment when the lower is equal to upper. Okay. Now, um okay. Now from what you can see here, it's the same thing. It's the same problem that we're trying to solve. But in this case, it's the solution is in recursive form. So as you can see, it starts with if lower less than equal to upper, right? But at the bottom here, what does it do? It starts to call display range and then add 1 to the value of lower, and then the same thing goes for upper, okay? So this is how it decomposes the problem into smaller sub-problems because um, it's just going to use itself, its own function, to have arguments that change depending on what iteration you are. So this is the first iteration, it's just +1. On the second iteration, we will still see +1, but the lower variable has a new value, right? Because it was reduced by 1 before. So anyway, we'll do a demonstration of this later. Um, Most recursive functions expect at least one argument. Yes, that's true. And so this is just another example. So as you can see here, our base case is if the lower is greater than upper, those two variables, what will it do? It will return the value of 0. So that means the moment that lower is greater than upper, what you will see there is just the 0 value. So that means after that, it can start going back up the chain, okay, or the stack, so to speak, okay? If not, then it will just what? It will call the function again, but this time with a higher lower value. So you start seeing um you start seeing functions being called over and over again with a different value for lower, and you just keep adding 1 to it. Okay. So it doesn't always have to look like this. It can have, you know, larger amounts. Okay, it can just be more than one increase in value, right? It really just depends on the problem that you have on hand. Okay. Now here, returns the sum of the numbers from lower to upper and outputs a trace of the arguments and return the values. So basically, we can sort of track a little bit what goes on to our function. All right. So this is the result of that function. So summation 1, 4, and 0. This is the lower, upper, and then the margin. Yeah, there you go. So that's the margin. Um, Hello, can you still hear me? Just trying
Yes,
to
sir.
make
Yes, sir.
Okay, just trying to make sure because I received a notification that my internet is slow. So I think there's something wrong with um my connection today. I'm not really sure. So this example is a bit more complete. So we'll try to demonstrate this one, okay? And then we'll try to track what's happening as the function, so looping or recursive, how the recursive function works by tracing it step by step, all right? So what it did was it defined a function called summation, right? It will accept an upper value. Um, Wait, let's start lower, lower, upper, and then the last one is the margin, right? Yes. And then um, let's start with the blanks. That's what it started with, blanks. And then space here. We'll add a space here because it's a blank multiplied by margin. Now, if you do this with text, right? Um, Basically you're just multiplying how many times it repeats itself. If it's zero, I think it's zero. So if the margin keeps on increasing, the number of spaces will also increase. So if you take a closer look, it's not like the two codes are not next to each other. There's a space in between. So you have to remember that one. Next is we can have a print statement because we want to see what's happening at that point in time of our code. So what do? We want to print the blanks, the lower, and the upper. Okay. Now, what are the blanks used for? So the blanks are basically used for so that we can kind of trace what's the next step is, right? So the more functions that it calls on itself, the farther away the text should be in the output because to demonstrate like how deep did it go or something. Um, so yeah, that's just the real purpose of margin here. It's not really related to um recursive functions in general. So after printing blank, what do? We check, right? Check if lower is greater than upper. Greater than upper. And then we print what? All the blanks and zero. Why? Because this is the last thing that should happen. This is the base case, our exit condition. Um, when the lower is greater than upper, then we'll print the margin or how long the margin will be, and then the value of zero at the end. Else, what will we do? We will save the result to a variable called result as well. So what do? We get lower plus summation and then lower plus 1, upper, and then margin plus 4. Right. So right here, we can see that upper remains the same. Lower increases by 1, and then the margin increases by 4. Again, margin is used to just add spaces horizontally. All right. Okay. Um, After that, so we're done with the if condition, right? We should try and check what the value of blanks is and also of result. And then, of course, you're going to return the result itself because this is what you get, right? This variable is what you will get. And that means you can return that one um, in the end of your function. Okay. So let's see. Important points are mm, yeah, I think that's all we need. I think this is good. So if we run our code now, it's not really stopping. Oh yeah, you have to call it first. Forgot. So summation, what was the example again? The example is 1, 4, and 0. So 1, 4, and 0. And then run this code again. Hmm. I forgot to return 0 here. Okay, let's try this one again. All right, there you go. So exactly the same as what we see here on our PowerPoint. Okay. Now let's go over this one really slowly because this is where it gets really confusing. So at the beginning, right, we are calling the function this one, summation 1, 4, and 0, right? So as we are calling that function, um, let's change this one into Markdown. All right. So as we are calling that function, we have 1, 4, and 0. Okay. We substitute these values to these parameters. So lower is 1, upper is 4, margin is 0, right? Now, blanks times margin, 0 times margin. So it won't add any space, right? The second one, print blanks lower and upper. This is what we see. So it says print blanks lower and upper. This is what we see at the top, right? And we are still at this point on the first um, run of the function, okay? Now, next what we see is a question. It's going to question if the lower is greater than the target, right? If lower is greater than upper, then what will we do? We will print only the value of 0 and then return back to whoever called it. Okay. Um, next is the else statement here. So it's gonna look like result is equals to lower plus summation, lower plus 1, upper, and then margin. So this basically is just another summation call, right? On a function called summation. Now, why are we doing this? Because how do summations work? All right. So, so basically the one after the number from before, right? That's the upper value. So in other words, if you add all those numbers, then you get the summation. And that's why we get these numbers here, 10, then 4, then 7, and then 9, and then 10. So 10 is the value of that one. Again, you just need to add um, the values that were indicated here. Okay. Now, what else? At this point, right? Python will see this code, and then Python will say, all right, I see a function call. Let's stop here for now. Okay, so we're gonna say, let's make it view. Where's the view? Line numbers. Okay. So what Python will do is that the moment that it sees this one, what does Python do? It evaluates first functions and the ones inside of it. So meaning it will what? Stop at line 8 and then run this code again because this is another function call. It just so happens that it is inside another function. That's why it's called what? That's why it's called a recursive function because it's gonna call itself. So let's just try and note here. Stop at line 8, right? And then Python will go back to the top. Why? Because this is where the definition of our function came from. Okay, the word summation. All right. Now the next line, what will it do? It will do the same thing, but this time with a higher lower plus one value and a higher margin. So um, let's try and put this one here. Okay. So stop at line 8. Stop at this code, something like that. Okay. Now, since we already know that the value of lower is 1 and then upper is 4 at the beginning, um, we can use that directly in our second iteration. So that means this function call here actually equals to what? It equals to this one. Summation. And then after summation, it's lower plus 1. What was the value of lower before? It's just 1, right? So all we have to do is add 1 to it. Then the value there is 2, right? Upper margin, comma, still stays the same. So that's 4. And then lower, where is lower? Upper is still the same. So it's still 4. And then as for margin, whatever the value from before was, it's just going to add 4 to it. So the value of margin before was 0. So it's going to become 12, right? Okay. So this is technically equal to this, right? Okay, so I'm just putting it there so that you guys can compare later on. Next is then it will call the summation function again with these new variables. It's gonna call again between these two variables. So let's see. All right. So 4313. And it's just gonna do the same thing. Stop at this code, will write implementation. just like that. So we'll start at summation again, but this time the values are different. So it's 2, 4, and 12. Okay. Now, the first line that we saw was this one, right? Blanks is equal to margin rate. So if we add that one here, right? So what will Python do? Python will just stop at this code again, and then it will go to summation. But what would it look like? So the result now would look something like this. So it only stops at number 2. Why? What is it? Okay. So this one here, so we stopped here at 2.4, right? And we'll have to copy this one. But then the value of lower and margin will increase because it's actually called again in the second iteration. So we're just gonna keep that one the same because if you remember the value for lower and upper changes with every iteration. So lower is just a key, up margin is just the space for our output here that we can see. Okay. Now it says here that on our second iteration, what we will see is what? Since lower is not greater than upper, okay, this will what will result. Okay, and then print the blanks and the result itself. My new blanks are my new blanks are or is the number 2 here. And 2 and 4, as you can see, this is what you also see here. Actually, it's not supposed to be 12. 2, 4, 8. Uh, yeah, class 4. Yeah, we'll just do the same thing so that it will be uniform. Because up here, it's using the same thing as well. All right. Okay. Now, in this section, Python will stop again at this point because it's calling another function, and that function just so happens to be himself. Now, as you keep on doing this, right, you can treat each rotation as a specific instruction on what to do. Okay. The only difference is that you can expand that instruction as many times as you want, and then it will adjust to what is available for us. Okay. Now you don't have to worry about that one. Here, right? We have to resolve this one first. So what happens to that part? It becomes summation So it's plus 1, it's 3. Plus is 4 is the same, then plus 12 is plus 15. Oh, no, wait, not 15. It should be 4, 4, because we started at 0, right? This is 8. Right? So always in steps of 4. Okay. Now, at this point, what happens again? Mm, what happens again? So on the next iteration, it will keep on coming back here, and it sees that the lower is still not equal to upper. So we're gonna have to repeat the entire same thing. So we're gonna stop at this code summation, and then what would happen afterwards? Right. And after this, what do we do? So it's a 3 at 4, right? 3 is still not greater than or equal to 4. So it's gonna proceed and add 1 to it, right? And at this point, upper right now is um, in the correct spot. So 3.4 and 8. Stop at that value. I mean, we can show 5. I think let's try to show 5 as well. Um, let's see. 4, 4, 8. Okay. So if you've noticed, we're just doing the same thing over and over again. The only difference is the values that we are using. All right. Now the new value of the summation is now what? It's now 4. So summation 4, 4, 8, right? So what do? We stop at that zone again here, and then do the same thing. So stop at the summation, and yeah, it's already added 4. There is still one loser, and I forgot the text. All right. So stop at this code, do the same thing again. Okay. Say the same thing. But on the next iteration, what will happen to lower? What would happen to lower is that she will become 5. Then 4 is the same. And then 9, 4, 8, 12. So 12. And 1, 2, 3, plus 1. I got confused with the numbers. Okay, so at this point, it will do the same thing. It will stop here again, and then run again the simulator or the function. Okay, now Operate 2 plus 1, 3 plus 1, 4 plus 1. So instead of 12, oh, that's 4, oh no, that's 5, 4, and then 16, right? Um, at this point, do you remember what happens? So when lower is greater than upper, this will trigger, right? If lower is greater than upper, then this will trigger. It will print blanks and 0. So here it is. You can see there the blanks and the 0 that it is paired with. Okay. Same thing with the other simulations that we have for summation. So we have 1 to the thousand, 2 for the thousand, 3, 4, right? And then we'll stop here. Okay. Now, um, you can imagine this one as a kind of a stack of plates, right? So each time that you call a function, you're gonna put one plate. You call a function, you put it in another plate, right? And you keep on doing this until you reach the end or your base case. Okay. Now, if we were to continue this one, um, we have a function here that part of it will print out the word match and then the parameters maybe. Um, Ah, sorry. All right. Where did I stop?
Sa ano sir, yung nung nag-return po ng zero.
Ah, okay. So this one, this line, right?
Yes sir, yes sir.
Okay. So at this line, it's return 0. So if we pass this one back at the top here, um, because this is the line that we stopped at, right? And this line is basically equal to lower plus summation, whatever lower upper margin was at that point. So that's why we say lower plus 0. Now lower at this point in time was 4. So we put 4 plus 0 here, which is just equal to 4, right? So now we have a final answer for this function. Okay, now where did this function call come from? From this location, right? Okay, so if we convert this one, it should be lower plus this one. Lower at this time is equals to 3, right? And then we say that this is passed back to the top here. So this is equal to plus 4, or if we just expand it, it's just 4 plus 0, right? If we want to go back to the expanded form, not because we want to see each function. So you can kind of get what's happening here because this one is passed here, this one is passed here, right? Now we have 3 plus 4 plus 0. Now, um, this is the answer for this function call. Now we have to go back and pass this one more time to the top. Okay, we are removing one more plate from our call stack. And we pass this one back here to the top, right? Now what does this equal to? The lower variable is equals to 2 at this point. And then what is the summation? Okay, what's this? So it's just this one, right?
7. Yes sir.
Yep. And then all we have to do is just pass this one back here. Okay. And finally, if you get the idea, what happens here at the top is just 1 plus 2 plus 3 plus 4 plus 0. So if you add all of them, what do you get? You get the answer of 10. And that's what we get at the very end here. In fact, if you try and see the sum here at each point, it's 0, you get 0. It's 4, you get this 4. 4 plus 3 is 7, 7 plus 2, it's 9 plus 1 is 10. So this is how recursions work, okay? At first, you keep on stacking plates, stacking function call upon function call. And then the deeper it goes, okay, see, this is the point of the margin parameter, because it allows us to see properly, right, each function call that's happening. And then the print statements allow us to see what's happening with the values inside, if this will just stop moving like this. All right, now, and at the end, when we reach the part where um, we are returning 0, right, the base case, then we start going back backwards. Okay, we start removing plates from our stack, so to speak. And then we gradually solve each problem one by one until we reach the final answer. So that's how recursions work. Were you able to understand it, RJ? Or do you want some clarifications? Hello, RJ, you're still there? Hello, RJ? Let's go ahead. Okay, RJ, let me know if you have questions before we proceed or some clarifications.
Wala naman po, sir.
Okay, so that's good. Um, right. Because at this point, this is just a very simple problem here that we have. Most other cases for recursive functions is very difficult. Again, recursive functions for me is just it's very efficient, mathematically efficient, but it's best to use this one when you are making your code efficient. So somewhere near the end when you are refactoring. So again, focus first on making your program work, however inefficient may be, and then you start refactoring your code to make it better, more efficient. And that's the time where you can apply recursive functions because it's very difficult to think of a solution like this one, right? It's not that straightforward, really. Okay, so here is another example, but it's just the Fibonacci. So the Fibonacci sequence is just the two numbers from before added, and that's the sum. So here's an example: 1 plus 1, 2, 2 plus 1, 3, 3 plus 2, 5, 5 plus 2, 8, and so on and so forth. It's actually never ending. Now, the way that they did this is that they kind of anticipated it if you were like somewhere along the line on Fibonacci. So what they did is they determined the base case first. So what is the base case? So if n is less than 3, okay, now what is n? N here is the n here is the nth sequence. So if you say n is equals to 1 is the first one, n is equals to 2 is the second one, third, fourth, and so on and so forth. Now, why do we want return to 1 if it's less than 3? Because you need two numbers first in order for it to work. So this is what we get at the beginning. This is our very base condition here. So when n is equals to 1 or 2, um, the function will just be equal to 1. Okay. Now, for all numbers with an n is greater than 2, this is what we will use, right? Because now, if it's greater than 2, then it has two numbers before it. And we can use that one to add to get the final answer. Okay, because if you want to get the second number, it's just 1. The first number, it's still just 1. So let's just remove that from the complicated equation, right? It's kind of annoying to think of what comes before that, right? In order to just to fit the definition, we could just directly just say it's equal to 1 when n is equal to 1 or 2. Or, right, if that is false, um, then it will go here to the else statement where it will get the first number before it and the second number before it. So if you say um, Fibonacci of 5, so this is 1, 2, 3, 4, 5. Okay, this is the fifth one. Now, if it's fib n minus 1, so that's 5 minus 1, so that's 4. This is 4. If you say plus fib n minus 2, so that's um 5 minus 2, so that's 3. So this is 3. So 3 and 4, you add both of them, you get 5. So that's the logic behind this one. And the reason why the solution looks like this is because that's already in the definition. Okay, so some recursive functions actually come from their definition itself. Okay, so this one is a bit easier compared to the one earlier. Okay, um, so this is just one application of the recursion. If you remember our sentence structure, right? They made it's just a partial look at the function that they have. If you remember, we didn't have the complete program for that. We just take a look at how the program flows supposed to be. Um, and this function, the noun phrase, returns a noun phrase, which is an article followed by a noun and an optional prepositional phrase. So what does it do? We have here where it's using a random library, so random the choice articles plus a space and then plus the nouns randomly chosen. Then we have the probability, okay, 1 to 4, so that's 25% chance. If the probability is equals to 1, right? Then it will add a additional phrase, a prepositional phrase. But if it's not, then it will just return the original phrase. So if you think about it, there's a chance that it will keep on being equal to 1, and it will keep on adding prepositional phrases to the one before. But um, it depends on chance. So at this point, it's not really in the definition that's um, creating the recursive definition that we have here. It is basically just a regular recursive problem. All right. So yeah, we're not going to be making a lot of recursions. It's honestly it's a bit difficult to create one involving real world problems. All right. So infinite recursions occur because we forgot or we didn't specify properly our base case. So at this point, if um our function here run forever n, and then if n is greater than 0, then it will call the function again with the same value of n, right? Else, it will call the function again, but with a lower value of n. Now, if you keep on deducting 1 to n, then it will never reach the point where n is greater than 0. It will always keep on going to the other direction, the negative direction. So it will never run the base case. And what you will get is something like this, an error. Um, Run forever, previous line repeated 991 times. You can actually do this one if you want. It will probably depend on your device. In my computer before, when I tested this code out, I stopped at around 9,000 repetitions before it stopped by itself. Okay, so our modern devices have a way to actually detect that it's running an infinite function, and it will stop it by itself, of course. Um, so yeah, but it doesn't really work that way for real bugs that you can't really see that it's an infinite function, like in servers. So there's a chance that if you've made a mistake, then you will keep on generating cost because you're using those functions on the server, and they will keep on billing you on that one. So if it's an infinite function or an infinite recursion, then the bill will increase to the point where it's too high. So yeah, you have to be careful with that one. The cost and benefits of recursion. So let's see. Mm, for each caller function, the PVM must allocate on the call stack a stack frame which contains the values of the argument, return address, and space. So this is too technical right now. Basically, it describes what's happening with each function call and how it knows where to return to after you get the final answer, right? Because we keep on calling functions and then we go back to where we came from. So it has to have some kind of return address, so to speak. Um, but yeah, this is a bit too technical for us right now, but it just shows how it works inside. So it has the values of the arguments, the return address for each function call, and the space for the function call's return value. So um yeah. So each frame that it has, each stack frame, right? Um there's a certain resource used for that one, and each time that a stack is done, right? um, then that resource is also freed up. Okay, so there's a note here, amount of memory needed for a loop does not grow with the size of the problem's data set, but it can still affect it. So it's not an absolute in that case. All right, so this is a visual representation of a stack, but yeah. So call one, or the first time that we call the function, we have the lower and upper, right? If you remember. Then this is the second call. We have the lower and upper, third call, fourth call. Now, if you see this one, right, it's a lot better to imagine this one if you're calling a like it's a plate. It's the best analogy that I can think of. Each call is a plate, all right, something like that. And this is actually the origin of the name um Stack Overflow. Like if you were researching for answers online for our exercises or um other informations, if you've encountered errors, so you'll most likely encounter the Stack Overflow website. And this is exactly where that came from. So when the stack reaches the maximum amount that the device can handle, then it will start overflowing from the container. So that's what it's called, Stack Overflow. Okay, so let's see. Where are we? Mm, all right, let's just continue. I think we can skip the exercises for now for recursions. I think it's better if we just continue and then start with web scraping once we're done with this. All right. Namespace. So basically, it's just for organization purposes, really. It can avoid naming conflicts, encapsulations. Um, Basically, it also makes our code a bit more modular. So when you say modular, you can easily take something out and put something in, and it doesn't really affect the program as a whole. So that's what it means to be modular. Um, if you want some kind of analogy for this, think of like I think of like a cabinet, so to speak, right? And then you have some drawers. So a cabinet still is just a cabinet, and then you can swap things out from inside, and it doesn't really matter. So that something like that. That's what modular means. You can just swap things around. So here is an example. Module variables, parameters, and temporary variables. Oh, okay. It just essentially okay. Um, All right, so this is from our doctor program, and this is the change person function. So here are the replacements, if you remember, right? It will change the um, point of view, right? So first person, second person. So the words I, me, my, it's got to be changed to their equivalent. So it's you, mostly you, then your, yours. And this function here called change person, you're going to pass the sentence that you have. It scans each word, right? It's using the split function, split method to get each word and then analyze each word. All right, take a look at each word and then using the append here, right? If that word exists in our dictionary, then you will replace it. If it doesn't exist, then it will just um get word. Ah, okay. The word itself. So the default word. It's not gonna change it. So this is the good thing about the get method. All right. And then in the end, it will return the whole thing. Return and then join. It will join all the words in our list here. Because remember, we split them up to analyze each word. And then at this point, we are adding each word that we have analyzed into this list. So we have to combine them in the end. So that's what we have here. Return string.join and then pass in the list that we have here in order for it to become a sentence again. So basically that's what we did. We break up the sentence into words, change the view, the point of view, okay, using this dictionary. And then after that, combine it again to make it into a sentence. Okay. Let's see. So we've already discussed this one before. Um, we know temporary variables. We have discussed parameters as well. Method names, yes. And module. Well, they do receive it because you're going to have to declare what they are in the beginning, so to speak. So it just makes sense that it says they receive their values as they are introduced because like why would you put temporary variables if you did not put a value there at the beginning? Okay, so it's just common sense at this point. Parameters, the parameters we have in our function. Method names, the one that follows after the dot. Okay, if you remember the dot method, these are called the methods, but essentially they are still functions. The only difference is that they work only on the object that they are acting on. So in this case, the split function will only work on the sentence, okay, whatever sentence is or whatever that object is that they are attached to. So that's what makes them different. Functions in general work with anything. Methods work only on the objects they are attached to. So that's the major difference. Scope. So basically, scope is just the limit of what you can access um, of the variables, right? So this is a very simple concept, but it can be, you know, it can be like missed sometimes when you have too many lines of code. So just be aware where they are and you'll never get lost. So for example, this is how it works. We have a global variable. Okay, we say that it's a global variable because it has a global scope. That means anything can access that variable. Okay, usually it's the outermost part of our code. Okay, um, if it's inside of a function, it's just not indented here. X is equals to 10. So we are attempting to what? Reset the value of X, right? And this is the function of x. Now, what happens when we call the function of x? Does it change the top level? So it says no, this will just display 5. In fact, we can do this one. Um, just a quick test, just to know how scope works. If, and if we want to see, just print it here, and then we'll call the function, and then print it here again. Okay, so we should be able to see the difference, right? So this is how scope works. Okay, so we declare it 5. We have a function that's changing the value of x, supposed to be changing the value of x to 10. But if we print it out, what we get is 10. So it's correct, right? But um, in this case, when we print x after calling the function, what we see is the global variable version. So it's the one where it says x is equal to 5. Okay. Um, so that's the difference. The scope here of this x is just within the function. All right. And then the scope of this x here outside is on a global scope. Anyone can access it. But the difference is that it's using the same name, right? Um, which you shouldn't really be doing it. A better way for you to avoid that kind of problem is to use unique names, meaningful names, right? So if you change this to Y, then absolutely you'll have no more problems in the end, okay? In fact, if you print Y here, you'll not see any values. Why? Why? Because the value of Y, the scope here, is within the function. It is only available while the function is running. After the function is done, it will release all the resources from your device, the memory, everything that uses up your resources will release it, and then it will not be available anymore. Okay, so that's why when you say print Y here outside, it's not anymore um, accessible. Okay, so the scope of Y is within the function only. Okay, I hope that makes sense. Anyway, it's not really that hard. It's mostly common sense, right? Like if you are deeper and deeper into your code, like if you have a lot of things like this one, and you keep on adding nest, right? So that the deeper you are, right, the more inaccessible they are from other parts of your program, something like that. All right. So the easiest ones are the global variables. So if you declare them outside, you can access them. In fact, anything above it, okay, say this is our nest, final nesting part, then anything above it, okay, this one has access to it. So it just makes sense, right? Because, it it came from there, so it should have access from everything that's before it, right? Okay. The lifetime. So basically it's not let's uh not overcomplicated. It's just how long will the variable last in your memory? Again, for functions, it will last as long as the um, function is working. Okay. It is destroyed or released the moment that the function is done. For global variables, it will never disappear until you actually turn off the program or your machine, right? Um, in this case, the lifetime here is as long as it's running as its lifetime. So yeah, parameters and temporary variables come into existence when um, bound to values during the call, but goes out when it is terminated. So, um, where is it? All right, so these parameters here will only exist once the function is running. After that, when it's done, then it will essentially disappear as well. Okay, same thing with what regular variables, right? And side functions. So yeah, just let me know if you have any questions so far. Okay, right, Jay?
Okay, sir.
Um,
Okay.
okay, what else? Using keywords for default and optional arguments. So we've already done this before. Creating default values for parameters, right? So it's just as easy as adding an equal sign here and then the value that you want to be a default. So when you have like when you're calling the function, but you did not include a value for that parameter, then automatically it will use the default value that you gave it here, like the number 3, for example. So it's we've already discussed this one, yeah, when we were discussing functions, so to speak. Okay, what else? So this is just us using the names of the parameters itself, right? Like we are declaring the keyword pair themselves when we are calling the function. So in this way, even if we swap them out, as long as we are calling them by name, they will be assigned properly to their appropriate um, parameters. Okay. Otherwise, then you'll have to follow the sequence that they are declared. So if it's option 1, option 2, option 3, then that's also how you should declare it when you're calling the function option 1, option 2, option 3. If you were calling them by name, the parameters, then it doesn't matter their order in your function call um, because they will be assigned anyway to their appropriate parameters. So yeah, if you've memorized the, for example, the name of the parameters, then you can do this one. But most of the time, positional declaration of arguments is usually the way to go. So something like this one, positional arguments. You're just following what to uh, input next in your function call. Higher order functions. So we're finally in the higher order function. Um, so a short version of what higher order functions is are that these are functions that will accept other functions as part of its argument. And you can even save it to a parameter to be used later on. So here's a very simple application or an example of it. So we have an ABS function available in Python. The ABS function looks like this one, ABS, and then why did I delete it? Um, we have an ABS function here. And if we print this one out, ABS, -5, for example, right? If we print that out, it will just give you the absolute value. So this is what ABS does, absolute. Um, then we also have the math squared, but you have to import the math library for this. So import math squared, you have that function as well. Now, what we do here is if we assign a variable like an alias to the absolute, right? Then we can use that alias to do the same thing, like the actual function. So if f is equal to abs, then we can just say f negative 4. Then the absolute function is applied to this one as well because they're just aliases, right? Now, if you put them into like a list, this is what you get. So you have ABS and then mathless square root. You can actually do this one because it's just a reference to the functions. You are not executing the function per se because you did not put the open and close parentheses. You're just giving the list a reference to those functions, right? And this is what it looks like. Okay. Now, at this point, we can just um, call it like this one. So functions one. So that is the second part, which is the square root, right? And then you pass in a value of 2. So you're essentially looking for the square root of 2. And this is what you get for the final answer here below. So if you want to like put all the functions that you're using repeatedly into one list, you can do this one. But there are some other uses that is much more useful than this. So we're going to explore them next. So this is it's just showing you that usually for our arguments, right, when we are calling functions, you are usually passing arguments that are values, real values, but you can actually also pass a function if you want as an argument. So this is where higher order functions come in. This is where they um, begin. So there are three higher order functions that are very useful. We have mapping, we have filtering, and we have reducing. Okay. Um, if you want to master any one of them, I suggest you master mapping because filtering and reducing just came from mapping. They only made it separate in order to accommodate convenience, right? Because they found out a lot of people keep on using map just to filter things. They just decided, let's just create a different function for this that will automatically filter things. So that's why filter came out, and that's why also reducing came out. So if you understand how mapping works, all the other functions will um, come in very easily to you and understand it much more easily. Okay, mm, let's start with mapping. Again, these are not just the only higher order functions available. These are the most common higher order functions that you will use a lot. Um, the definition again for higher order functions is that they are functions that accept other functions as arguments. So as long as that is satisfied, they can be classified as higher order functions. Um, so let's see here. It says mapping applies a function to each value in a sequence and returns a new sequence of the result. All right. So it's pretty plain and simple. If you ever have a sequence like a list, for example, it's gonna apply a function to each one in those lists and then return a new one. Okay. So here's a good example. So we have a list here of numbers that are of a string data type. Now, we have used map, okay, and then the syntax for the map function is the first one is the function that you're going to use, and then the second one is the sequence, second argument. Okay, so we pass in int as the function that we will use, and then words as the sequence that we're going to use for a map. Next is it's just printing the words here originally. Next is um right. Basically the map will Mm, the map will give us an object if you just use it directly in this case. But if you use it with a list, something like this, okay, if you wrap it around a list, it will give us, of course, a list. So the way that map works is it's kind of the same with the range function where it gives out things one at a time. So if you use a list on that one, it will also be collected into one easily accessible list. So as you can see here, the difference between the words here and then the list here and the list below is that the one at the top, the original one, is made out of string. The one below is converted into numbers. So as you can see, just a simple list map and then the function that you want to use, we have essentially converted all of these strings into their number equivalents, right? So it's really that simple. So you pass in a function and then a sequence, and then that's it. That's how the map works. Okay. So here's another example. This is from the change person, the doctor program that we had before. So sentence and split. So this is the original one. This is the simplified version. So what it did is it defined another function inside. Okay. So this function, what does it do? It will just simply replace the word with the word that came from the dictionary, right? The things that converts the I to you, to me to you, if you remember. So what it does is that after joining it, right, instead of joining the words from this list, what it does is it will call the function to apply this function inside of it to each word that it has. Okay, so um, you can just put sentence that split directly in this section here because it's just a list. So it's basically a sequence, right? Get word is the one that we defined inside here, which will just get each word from the sequence, compares it, and then returns if it matches anything the original word or if it doesn't exist, then it will just return the word itself. So the difference between that one and this one, right? So let's see how many lines of code. One, two, three, four. Okay, let's just say four. How about this one? So this is just one, two, and three. So there's a difference of one line in this case. Um, so it might not seem like much, but if you're trying to conserve space, you're trying to conserve memory. Um, so this is actually really helpful in those cases. Um, so yeah, that's it for mapping. Let's go now to filtering. Now the filtering here is just as simple as mapping. The way that its syntax works is something like this. So you start with the word filter, and then you pass in the function, just like with the map, right? And then the range that you have here. So it is range or the sequence. So it's basically the same thing, right? The map and the filter. You pass in a function, and then the sequence that you have. All right. Now, mm, we are defining a one-liner function at the top. So this function will just return the odd numbers, right? So each item from the range here will be checked by this function, right? One by one, and then collect it into a list. So return n modulo 2 is equal to 1. So yeah. Let's see. So how will the filter function identify, right, which one to put in the final list and which one to avoid? Because uh, it's not really looking for values, so to speak. It's looking for true and false values exactly. So that's how filtering works. The function that you put inside of your function call must be um, using like Boolean operators, logical operators to get an answer of either true or false. If it's not in that manner, then a filter might not work in the way that you intended. All right. So filter is a lot easier compared to map. All you need, again, is a function that will return either true or false. Now, this one is using the equal operator. So it's comparing if it's equal to 1. If it's not, then um, just disregard that one. If it is, then get it and put it on the list. So that's why what we see here are only the um only the odd numbers, okay? Now you might be saying return and 1 modulo 2 is equals to 1, right? And the return here is what? True or false? So if it's true, then whatever value at the time the range is passing to the function, it will just add that value directly to the list, which are, of course, the odd numbers that we have here. So it's fairly straightforward, especially because we learned that one before. And last but not the least is reducing. So from the name itself, it's reducing two values at a time, right? To make it whole and then get another value. Um, Reduce it into one value until it finishes all the items, right? In the sequence. So here's an example. Um, we have an add and a multiply function, and it will return the sum and the product of both of them both. Now, if we reduce, right, we include the add function and then the data itself. So this is our add function here. It's very simple, return x, right? And then the data that we have is just 1, 2, 3, and 4. All right. Now, what does it do? Okay, it gets two items at a time at the beginning. So it gets 1 and 2, adds them together, then it's 3, right? It saves it somewhere in memory. Specifically, it's called the accumulator. So we have 3, right? Then it will get the next number and add it to what you currently have. So it's 3 plus 3 is equal to 6. Then do that again one last time. Get the next number and add it to the number that you currently have. So that's 6 plus 4 is equals to 10. And that's what we have here, 10. The same thing goes for multiply. Um, that's what also happens. Okay. And let's see, what else did I miss? Lambda function. So technically this is just for like saving space in your code because it's a one-liner usually. Um, Again, I want you guys to focus first on making your program work, not making it very efficient, very few lines of codes, and those kinds of stuff. So focus first on making it work. But just in case, how do you write a lambda function? So it's really quite simple. You just use the word lambda at the beginning, and then the parameters that you have, colon, the return, what will the return do? And then finally, if it will execute all of that, then um, wherever the lambda function was declared, it will return the value there, exactly there. So you don't have to keep on looking at where the lambda function was called in other sections because from the location where it was called, that is also the location where the result of the expression is returned. So you don't have to worry about that one. Okay. The parameters and the return statement is separated by a colon. So this is what it looks like. Okay. And it even combined it with the reduce. So in this case, sum and product are very simple operations. You can use them like this one and it will work. But lambda functions are not really recommended for complex problems. Okay, you should avoid them because they are not that flexible, really. They're good for simple operations like this one. Okay. Um, what else? Jump tables. Basically, this is just a table of functions that you can do. See, insert, replace, and remove. So instead of like calling the name of the function, you can just call your table and then the name or the key that you're attached to in that case. Um, yeah, that's it. So technically, this PowerPoint is mostly just um, for like additional knowledge for you guys to have, but it's not really that important at this point in our lessons. So yeah. 2:48. Yep. We can have our break for now, Sir RJ. A 15-minute break. And then when you come back, we'll proceed directly to web scraping. So hopefully we can finish more than half of it. And then by next week, we'll continue finishing it. And then we'll learn pandas. And that will be our last session together. Okay. Any questions so far before we take our break?
None so far, sir.
All right. So just be back here by 3:05 or somewhere around that number. Okay.
Okay, sir. Thank
All
you.
right. So have a good break. Hello, hello.
Hello, sir.
Okay. Can you see my screen?
Yes, sir. Yes, sir.
Okay. So we're finally beginning with web scraping. Let's see. Okay. So we're gonna have to discuss first how the web works a little bit. Um, just so that we can understand what we're trying to get and why we need it. So um this is a very basic uh overview of what happens when we are web scraping. So this is our browser on the left, and it's trying to use the fetch protocol, or this will technically look like a function if you look at it using JavaScript. And when you use this function, it's gonna request for the web page, right? So using request, basically, if we are using Python, we're going to be using the request library in order to um, simulate the browser in this case. All right. So what are we trying to fetch? We're trying to fetch the web page, but specifically, we're trying to fetch the HTML file. Now, the HTML file is short for hypertext markup language. This is basically the backbone of every website there is. So everything that you see in the website, like the styles, the behaviors, the animations, all of those things are attached to the HTML. So there's no website really without the HTML, so to speak. So it's literally the skeleton of any website. And in this case, that's also where all the data that we are trying to look for is located. It's inside the HTML file. So that's what we're trying to access in this case. And so let's say that we have the HTML file in our program, right? We have downloaded the HTML file. What do we do next? So what we do next is to, of course, extract the data from the HTML and then make Python understand the structure of the HTML so that we can get the HTML tree. Okay. And how do we get this? By using the library called Beautiful Soup. So this is the basic flow of how we're gonna extract data from the web. All right. So yeah, let's begin. Um, HTML basics. All right. Now, um, right, let's start with tags. Now, tags look like the following. So it has a beginning and an end. So let's say, for example, the head here. So this is the beginning. The end part, the part name for this one is this one. Okay. See, they're both head. And then the ending part always has the forward slash in the beginning. So that's how you determine that that's the pair for the tag. All right. So they always come in pairs. Not all of them. There are some that are the exception, but most of them have an end pair. Okay. So there's a beginning and an end. So if you observe the other parts, we have body, body, H1, H1, UL, UL, LI, and LI. Okay. So as you can see, uh, HTML and HTML as well. Okay. And in between the beginning and the end, we have something called the inner HTML, right? So in this case, this is the inner HTML text, all right? The text that we see inside when we view our website, the website, all right? So this is the inner HTML text, this one, and as well as this one, okay? Now, um, every tag, every opening tag, so the beginning, always has attributes and its value. Okay, so the one in yellow is an attribute. The one in red is the value for that attribute. So how do you assign a value to an attribute? You use the equal sign, basically. And the value is always going to be um, a string, okay, with quotes. There are some attributes that you can just put numbers directly, but most of the time it's uh, a string, basically, right? So that it won't get confused with other stuff in your program. So yeah, this one is another example, the ID, and the value that it assigned to the ID is list. Okay, so tags, inner HTML text, attributes, and the attribute value. So you following so far, RJ?
Yes, sir.
Okay. So of course, different tags mean different things, and it also has different uses, but it's not really our place to understand all of them. We're just gonna focus on um, not the most basic ones, but the ones where the data that we need are almost always found. Okay. So these are the top HTML tags that we see a lot when scraping the web. All right. So first is the head. Now the head is usually where the information about the website is located. All right. Like the name of the website, the description of the website, who made the website, the address of the website, um, the language, what else? And other settings that it has. Like um, is it downloading pictures from somewhere to display on the browser? Is it downloading specific files for JavaScript or CSS for styling? So it's all in the head tag. Next is the body, okay? And it contains all elements inside the page's body. Now, basically the body is the one that you see on the browser, okay? The page itself, that's what's inside the body, okay? Next is H1. There's actually six of them. So it's from H1 to H6. H1 is the biggest, H1 is the smallest. But this is in terms of font size, okay? Their default um, sizes, so to speak. So H1 is the biggest, H6 is the smallest. H is short for headers. So um, topics are usually found in headers. So this is one thing that you should look for, all right? Especially if the website is well made, they are following the proper uses for the tags, then you can use that one and collect the information that you want more efficient, right? So why do they do that one? It's because Google and other search engine likes websites that follow the proper uses of the tags because it makes it a lot more easier to search for other people. Okay, so that's why search engines tend to give a higher rank to those websites that follow proper tag uses. Okay. Um, A or the anchor tag. So this is used when you want to put a link to a word, right? You ever seen those things where you click on a word and then it takes you to another website or another page or another part in the page itself? Okay, all of them are in an anchor tag. So that's very useful. Paragraph basically is just a paragraph, right? It's the main content, one of the main contents that you have. Um, the div, so used to create a division in the page. So it's not really the where content is stored. It's more like you use the div to locate the content, right? You use it as some kind of um, waypoint for you to go to access other things. Okay. The span here is used to style individual parts of a like paragraph, for example. So let's say you have a paragraph that um, has a certain word in the beginning, like the, right? So you want to add styles to that word, but only that word. So you're going to be using a span in that case. Okay. We have OL, UL, and LI. So this is ordered list, unordered list, and the list item. So ordered list is basically like 1, 2, 3, A, B, C, the Roman numerals, right? Ordered. It has ranking, so to speak. And then unordered is those lists without, of course, an order. So bullet points, dashes, it can even be symbols if you want, right? You can customize it the way that you like. And then LI is always inside of OL or UL. Okay. So you'll always find LI inside of the OL as well. And last but not the least is the table, right? Now the table has this kind of setting or setup. So so you have a table, right? Markdown. So you have table, right? And then you have an ending table. Can I run this? Hmm. Sorry. Okay. So usually you have the T head and then slash T head, and then you have the T body, right? Sorry. And then you also have T footer. Okay. So T footer, I forgot the exact tag. I don't really use this one a lot when I'm creating websites. The T footer. So I usually put it somewhere else. The one that I use a lot here in tables is the T body. All right. Now inside of these things, okay, you can define and even further. So let's separate them here just to give you an idea of what they look like. All right. So don't mind the colors for now. We're in Jupiter. That's why it looks like that. Um, Under the T head, you should imagine that when you're making tables in HTML, you're making them horizontally. You're not making them vertically. So um, I'm gonna say TR for row, right? And then I'm gonna say TD for table data in this case. So um, but since I am at the T head, I'll use TH. Okay. So right now, you don't really need to memorize these things. I just want you to take a look at the structure of how it works. Okay. Focus on the structure. Let's say column one. And then we have another one here. 4 columns. 2, 3, 4. Okay, so take a look. That is what it looks like. Column 1, 2, 3, and 4. Why it works here, I am not really sure, but you know, that's this is actually the first time that I'm using this in Jupyter, so I'm not really sure why it's working. But anyway, it works. So T body. So in the T body, um, you are adding the data for each cell that aligns to that column, right? So we'll have another row here. Okay. And then you'll have, this time you're using TD because it's for table data, right? So data one. Wait, wait. So data one, row one. Okay. So this is data two, data three, data four, and it's not working. I wonder why. T body, T. Ah, okay. Does it like spaces? All right. Okay. Does it like spaces? Okay. So this is data one in row one, data two, row two, data three in row three, data three in row, data four in row one. So if you have another row, then it will become row two, data one, data two, row two, data three, row three, and so on and so forth. Okay. The T footer is somewhere near the end. So if I remember correctly, the T footer should also have a TH, or was it TF? No, it was just regular TD. Yeah. So put one. Yeah. So that's how a regular footer works. Um, so these are what tables look like in HTML. Okay. And this is their structure. So all you need to do to remember is it has three parts. So T head, T body, and T footer. You'll know it's a table because of the letter T at the beginning. And everything is inside the table tag. Um, it should be defined by each row. Okay, each row. And then the data is for each column on that row. Okay, so you have to remember this structure because it's kind of confusing, especially if it's your first time. Okay, so that's how it works. It's just showing three tags here, basically because those are where the data is usually are. T head, TR, and T. Okay, any questions so far? All right,
Okay.
I'm guessing it's done. Um, right. This time we're gonna have to install first our first um library. Okay, so we're gonna learn how to install third-party libraries um in our devices. Okay, so I'm gonna have to switch my screen here, and I'm gonna be sharing Anaconda Navigator. All right, so this is my Anaconda Navigator. So what I want you to do first is you're gonna have to go to environments. All right. And then after clicking on environments, just let me know if you're not following, okay? So after clicking on environments, what you're gonna do is you're gonna click on the channels button, okay? So something like this will appear. And then what we'll do is It's actually a lot here, but just don't mind those other things. What I want you to do is to click on add, right? And then add the following. So you actually have to type this one. So just be careful with the spelling. HTTPS, right? Word for word, and then conda dot anaconda dot org slash conda forge, right? So this is the exact thing that you should put. Now, Conda Forge. What is Conda Forge? Conda Forge is well, like a group or a community where third-party libraries are stored and also um, like stored. Yeah, I think stored is the correct word. Um, like a repository. So we download all the things from there. Uh, and all the updates will also go there if ever these libraries are updated. Okay. Now, after writing this out, exactly like what I have here, you press the enter key. You have to press the enter key. Okay. Invalid channel. All right. Why is it invalid? Conda that anaconda that word. Conda. Why is it not working? No, I'm not. Oh, it worked for you. Okay. So that's good. I think it's because if I'm correct, I already have it. Ah, yeah, okay. So that's because I already have it. So that's why it's an error. Okay. So after adding it, right? The green button should appear here for the update channels. So I want you to click on update channels. Okay. And then after clicking on update channels, what you're gonna do is right here. Um, you're gonna have to look for the beautiful soup library here. Okay. In this um in the navigator itself. So you're gonna say something like you're gonna have to search for it. So click on this drop down, make sure that you have selected all. Okay. And you should finish the update channels first, okay? So that your list here has been updated. Okay, so all the things that is listed here is the one from Conda Forge and also from Anaconda itself, the libraries that they have. So um, change the drop down to all and then search for packages, right? So what I want you to search for is BS4. So BS4. BS4. All right. So I already have it checked here, but in your case, it should be unchecked. All right. Now, what I want you to do is to check it. All right. And then, um, yeah, let's discuss this one first. So this is the name of the library. This is the description, right? So you can see Python library designed for screen scraping, and then the version number. So when there's a blue arrow here, or when everything is blue, it indicates that there's an update available. So you can click on this one and then it will update automatically, right? But what if you want to install something? So I'm going to be using the one below for demonstration, but you should be clicking DS4. Okay. So click on the box and it's going to be a down arrow. Okay. Then two buttons will appear here, right? On the bottom. Then you're going to click on apply. Okay. Now it should have some, um, if I remember correctly, there should be some dialog box that appears. So it should show you that it's downloading, right? And the amount of time that you have to wait for it to finish. So when you click on apply, let me know and tell me what you see so I can guide you from there. Or if you want, you can share your screen if that's okay. You can share all participants. There you go. Okay. So let me know when you are at this step. Okay. You'll know that it's installed because it will show a check, just like this one. All right, so the following packages will be modified, solving. All right, so just wait for that to finish. It's still installing. Um, right. So while that's installing, um, I'm gonna have to change my screen for a while. Okay. So sometimes it takes around 15 to 20 minutes. It depends on the device and also the internet connection that you have. So let me know when it's done. Okay. And while we're waiting, we'll just prepare. Okay. All right. So again, beautiful soup is what we'll use. All right. But why is it BS4? Okay. Now, BS4 is a library and there are other things installed besides beautiful soup. So beautiful soup is just one of those things inside BS4. I hope you understand. Um, Beautiful Soup doesn't fetch HTML. However, it is good at extracting information. So this is what we'll be using to what? Navigate the HTML file. This is what we will be using to make Python understand the HTML file. Once Python understands the HTML file, it can um, parse it, right? Then we can play around with it much, much easier compared to us scanning the file itself because it's actually very difficult if you were to scan the HTML file itself, right? So I'm going to show you that one later. For now, I want you to type this somewhere, right? You can just follow along. Um, Type it somewhere, just so that you can just copy and paste it later on. Okay, so right now it's marked. I'm gonna make it marked down, and then um, where's it? Okay, I'm gonna copy this, right? Yeah. So let's see. It starts with what? HTML followed by head. What's inside head? Title. All right. Mm, yeah, correct. Title, right? So my website, right? And then after this one is a T body, right? Inside the T body, you have an H1, I think. Yeah, an H1, UL, and three LIs. Okay. H1. So what will be in my H1? I'll put here my name is blank. And then I'm gonna have a UL, right? This is slash UL. Okay. And I'm gonna have three LIs. Okay, one, three, five, then one, five, two, item three, right? And we're gonna have some attributes here. So ID is equals to test, and then class is equals to my class. Right? So just very basic examples, right? Okay, copy this one first somewhere, and then let me know when you're done. And also check your download if it's done also. Any update, RJ? All right, so you're not sure. Can you do a screenshot? Try clicking the blue one, the blue arrow. I think it needs an update. It should be a green check mark on the left, and then the blue one should be the one on the right to indicate that there's an update needed. Yes, yes, exactly like that. So yeah, I think that's it. So what they have actually is the um 4.12.3. So that means there's a version that's more updated, but it's not the default file that it's downloaded. So you can update it later if you want. Just let's just stick to that. I'm sure it will work. Um, if we just use the default, it will still work. So yeah. How about copying the HTML that we have here? Are you done? All right. So let's continue. Next is we're gonna try and display that one in our Jupyter notebook here because this can actually display some HTML as well, like you've seen earlier, right? As well as graphs. So this is actually what makes Jupyter Notebook very flexible. It's kind of like a presentation and a discussion as a whole. So um, what should have been done is like the topic, and then after that is the discussion code result. That should have been the proper way if you were looking at an official Jupyter Notebook file that's made for self-study. But in this case, we're doing a bootcamp, so we don't have that format. But um, yeah, so all we have to do here is copy this one, right? And then it says some HTML string. So we're going to be passing an HTML string here, all right? So I'm going to say that, okay, hang on. So we're going to have to declare this one as a string because we're going to be passing this one inside of the function. So we're going to name this one my HTML string, okay? And we're going to put everything inside of a multi-line string. Convert this into code, and this is what we have, okay? So it's now a string, right? Next is we're going to declare or we're going to copy the line that we have here. So from IPython, right? So from uh, IPython, the core, was it the capital I? Yes, it's capital I. IPython.core.display. From there, we're going to import display and also HTML, these two functions. All right. Next is display and then HTML inside. So we're going to call display and then we're going to call HTML. So you don't actually need to memorize this one for now. This is just so that we can uh, like preview the HTML inside of Jupyter Notebook. Um, so yeah, so we're gonna say string. So my HTML string run invalid syntax. This is in what? Line one? Line one. All right. All right. So here you go. This is the equivalent Okay, the preview of our HTML here. Okay, the one at the bottom. Okay, this one. So this is the output that we're looking for. And this error, in order to fix this one, then we can just say, mm, please import from Python display. Um, so there's no need for core anymore. All right, there we go. So the error disappears now. Just remove the core and then it should be done. So, right. So you've made your first HTML page. So that's good. Um, you can actually find this file here if you want to save it as a file, like um, we can you can actually open it as a file. There's an attribute, no, actually there's a parameter in HTML where you can pass in the file. So if you have a file, we can use that parameter file and then load the HTML. But in this case, we are placing it here, okay, inside of our variable. So you can just pass it directly like this. Okay, so did it work? You have this displayed on your end. So that's a yes. Okay. Basically, you're just gonna be using this line over and over again. So um, you can just copy and paste this one always because you're gonna be using it anyways. Next is um, we have the HTML file. What we need to do is to feed it to our um, extractor, right? The beautiful soup, so that we can then use Python to navigate our HTML tree. Now, you might be thinking, where is the tree? So actually, when you take a look at this, right, and then you were to draw them, so to speak, by tag. So you start with what? There should be an HTML tree here somewhere. Oh yeah, there it is. So you start with HTML at the top, right? What's under HTML? So if you take a look here, there's only two. So it's the head and then the body, right? That's what we have here, head and the body. What's under the head? Title. So that's what we see here, the title. H1 and UL is under the body, and three LIs is also under the UL, right? And if you draw them like this, it kind of looks like a tree. That's why we call it an HTML tree. Once Python understands this tree and all the attributes and all the names that it has, no matter how big your file is, Python can go up and down like it was just its playground. So that's why it's important to have something like Beautiful Soup, right? So we can use its um, extracting feature to make it easier for Python to get the data that we want. All right. Okay. Mm, next is, so we have something like this, right? HTML string, right? So this is us trying to view the HTML like it was a page on our browser, okay? But it's too small. That's why it looks just like this. It's too small. But in this case, in our next example here, we're gonna be using beautiful soup in this case. So for now, I'm just gonna comment these things out. Okay. We are gonna import beautiful soup. Okay. So we're gonna say from Usually it's at the top, but I'll just put it here um, so that we won't get confused. So from um, what BS4, right? We're gonna import beautiful soup. Make sure the spelling is correct as BS. All right. So what we're doing here is from this um yeah, I hope I'm not interchanging this from this module. We are importing this library, or do I have that one in reverse? Uh, whatever it is. Beautiful soup is just a part of BS4. That's what it's for. And then using the import, we're just gonna import what is needed. So only beautiful soup, right? We don't need to import everything that's inside BS4 that we don't actually need to use. Okay, that's just more space than needed. And it's just a waste of space. So especially if you have a server somewhere for your project like this one, you're gonna need all the space that you can get. So unnecessary things are most likely not, you know, that you don't need should not be imported. So only import what you need. And then the as here, as BS, we are assigning an alias to Beautiful Soup because it's kind of long, right? And there's actually a chance that we'll have an error in the spelling. So we're just gonna name it as BS for short. Okay. Next is we're gonna what? Okay. What do we have here? All right. So we can just go directly after importing the file to soup. We can go directly to the two most common functions, methods available in Beautiful Soup. All right. And then some examples afterwards. Okay. Um, so from BS4 import to sub SBS, then we can say, since we have the string here, we can just directly say soup equals to BS and then pass in our string, my HTML string in this case, and then let's see if it will create an error. Okay, so no error when I ran it. So that's good. Um, yeah, okay, I think this is good. Next is we're going to be using the two most common methods of find and find all. These are the syntax for these methods, okay? So the parameters are as follows. Both of them have the same parameters. The only difference is the limit, okay? So we have name, attributes, recursive, text, and words. And let's see what each one does. So the name, of course, is the name of the HTML tag search for. The next one is you can search for multiple tags in the same time. So by using attributes, its odds are it's going to have a um, multiple matches, right? But if you're using the find, it only finds the first occurrence. Okay, so whatever it finds first, that is what it will return. If you're expecting that there's a lot of the same name, same tags, the same attributes, then it's better if you are using the find all. Okay. Recursive, you set this one to true if you want to look in the entire tree, or false if you only want to look in the immediate children. So what does this mean? So if we go back to our tree here, if you set that one to true, right? And if you were here in HTML, right? Let's say you are currently here, um, and you want to search for a certain text. So if you set that one to true, um, oh wait, this doesn't apply. Let's do the example again. Let's pretend that we are in body. Okay, we're in the body. And then if you set the recursive to true, and then you're looking for the, say, like, for example, the word mug, right? Then it will look at everywhere in the tree. So it can go here and it can also go here, right? But if you set that one to false, then it will only work from starting at the body and anything that's under it, anything and everything that's under it. So it doesn't involve the other things outside of body. So it makes it a bit faster if you know where the thing that you're looking for is found. If you are absolutely sure that it's under the body, then just search it there. Okay, it's much more efficient and um, you'll find the thing that you need a lot easier. Okay, text is searching for the exact string in the HTML tree. So this is the inner HTML text. And then finally, limit is the number of matches too. All right. Now here are some basic examples that we can do. So if we, oh yeah, I forgot the quarks. Quarks are keyword arguments. So in HTML, you can actually create your own attributes. That is actually allowed. You can create your own attributes. Before, it was kind of like a restriction because everyone was just limited to whatever attributes HTML had at that time. So they decided that it's actually better and much cleaner if you can create your own, have the ability to create your own attributes. So that is where keyword argument comes in because other websites have different attributes that they have. So you can use this quarks to look for them specifically. Okay. All right. Now here are some examples that we can do to simulate, right? Basic search in our uh, HTML file here. All right. So if you say print and then what we, this is our soup, right? This is an object. So if it's an object, what does it mean? It has properties and methods. So soup dot what? Find. Gonna use the find, and then we're looking for H1. So the arguments here are what? Strings. You're gonna be using strings. So if I run this code, incomplete. What am I missing? Oh yeah, another parentheses. So from what you can see, it will display the whole thing, H1, right? And then if you want to get the text only, right? This object, okay, this is still an object, right? It's not yet like a string. It's still a soup object, beautiful soup object. So meaning you can still use properties and attributes on it, properties and methods. So one property that's very useful is the text property. So if you use dot text here, you will get only the text value. So this is very handy later on when you know where the data is located and you only want the text value, right? So you can do that one. Um, Another thing that you can do, and let's separate them here. Um, okay, so another thing that we can do is we're going to use the um, find and find all the difference between them. So if you say print soup.find, and then we're going to be looking for li. Okay. Now we know that li here has three instances, right? So if I run this code, it will only print the first one that it finds. So item one. But if I were to say find all with an underscore, it will give you a list, all right, of every um match that it found. Okay. And every match that it found is also an object, meaning if it's an object, then you can use what properties and methods, whatever is available with that. Okay. Now, um, let's see. Oh yeah. So in the case where we want to get all the text, right? You can just use a normal for loop, or what it uses here is the um, list comprehension to get all the text inside of those soup objects. In this case, this one. All right. So this is still a soup object. A good way to notice if it's still a soup object is um, the tags are still visible. So that's how you'll know that it's still a um, soup object. Because at this point, when you say dot text, this is now a string object. So when it's a string object, then you can use things like upper, right? So you have to remember what data type you are working on. Okay. So up until this point, dot text, it was still um, a soup object, right? But after you said dot text, then it becomes a string object. So at that point, you can use string methods and string properties. Okay. Next is what if we have multiple lists in the code? Um, multiple lists. That's what we did here. No, it's not like multiple lists. It's more like how to use attributes to look for those things. All right. So it's whenever you're using the attributes parameter, okay, and you want to indicate multiple attributes to look for that specific thing, this is how you should declare it. I was confused with um the title of the slide. So if you were to like say print and then soup dot find, and you're using the attributes to look for it, okay, ATTRS equal, and then you're going to be using the dictionary, okay. In this case, mm, you're going to have to separate the attribute and the value, and both of them should be in string format. So in this case, class or ID, let's start with ID. The ID is what? Test, okay? You have to separate them with a colon, just like a regular dictionary. And then you're going to have to put a comma to separate each key value pair. So ID, and then class, and then my class. There we go. So if we were to run this code, it's incomplete. I'm lacking one. Yeah, there we go. So now this is our soup object. Okay, we have found the list that matches our criteria in this case. Okay. So if you're looking for something very specific, you can use multiple attributes to look for that specific tag in the HTML. Okay. All right. What else? If you encounter this one, you can just visit this link. Basically, this is all the code that I have. It's the same thing that I was typing here. So if you want a reference, you can do this one as well. You can just copy and paste it if you want. Um, yeah, or it's here. It's also written here. Okay, so generally, this is how we um, name those things when we are assigning relationships from one tag to another. So for example, we are at the body. Okay. Now at this level, right, you can determine the level based on like if you're having a horizontal line here. So at this level, right, everything that it touches at this level is its sibling. So in this case, the head and the body are siblings. Now, what's above them? It's the HTML, and we call that the parent. Okay. If there is something above the HTML, we call that the ancestor. We call that the ancestor, right? And that's about the limit of what we give them names to. Um, but under the body, right, we have children. So we have H1 and UL. And UL has children of its own. So it has three LIs here. Okay. Now, in relation to the body, the LIs are descendants, right? So we have ancestors, we have descendants as well. So it's kind of like just jargon. You're gonna hear this one often when you're um, doing web scraping works. So you're gonna hear these words often. And then we have these um, methods. So you can kind of guess the names from these things. So you want to go to the next element or the next one after the next one. So there's two next here. Or you can access the previous sibling or the parent. So those are some of the method names that you can use. All right. Okay. Now, for these things, you can explore them if you want. If we're not able to discuss them today. You can search for them and try it out for yourself. But for now, we're gonna do some actual web scraping from an actual website. Okay. Now we're gonna try and visit this one. I'll give you the link for this. I'll give it on the chat. For those that are viewing the recording, you can just search the title and it should also appear. It's fairly common, by the way, because it's just in Wikipedia. So just look for the list of countries, and it should look like this list of countries by coffee production. So, yeah, we're gonna try and scrape this website. This is an actual website. Where is my video? Okay, hang on. I seem to have lost my. Ah, okay, there we go. So again, this is an actual website. We're going to be scraping this website, but you can't just scrape any website. Like there are some rules that we have to follow as well. Like you can't scrape sites with ownership, like um, what would you call that one? Where intellectual property, things with an intellectual property on them, like art or like publications. So you can't really scrape that one off the bat. I mean, you can, but they're not gonna like it. They can actually see you scraping the website. So the moderators, you have to be respectful to those kinds of things. Okay, so I'll give you some tips later on at the end. Okay, so again, let's explore this one first. If you visit the website and then you press F12 if you're using Chrome or Firefox, you're gonna be opening the um how do I say this? The developer tools in those browsers. All right. So have you ever seen this one before, RJ?
Yes, sir.
Yes, sir. All right. So did I introduce this one to you guys before?
Hindi, sir. Pero may prior knowledge na po kasi ako sa HTML,
Yeah.
CSS.
All right. So that's great. Okay. So um over in this developer tools, right, that all browsers have, um, some might have different tabs than the others, but usually they work the same way. Okay. Um, the most important thing here for us as data scientists is the elements tab. All right. Now, in the elements tab, it's loaded here, the HTML file that the page uses. So as you can see, this is the HTML file. Now, it may look like it's just a few lines of code, but actually that's not because, for example, if you were to take a look at this class attribute, right? There's a lot of classes there that's indicated. There's also the lang attribute, the dir attribute, okay? But if you, like, say, for example, the head here, okay, let's just collapse these things. If you were to expand the head, right? These are everything that's inside the head. Mostly it's styles and meta. So meta is actually one of the things that we're looking for because this is a description, most of them, of the website. Hmm, yeah, like this one, OG title, list of countries. You also have the viewport if you want to get the viewport, the height, the width, the image that it uses, those kinds of things. But it actually doesn't have the other stuff. So usually there's meta description here, author of the website. So in this case, it's just showing us the title of the website. So the title is what you see here above your um browser and tab. So if you change this one to something like, I don't know, my name, for example, you can actually do that one, see it changed as well. But yeah, so let's skip the head for now. Let's go to body because again, take a look. What's great about this is that whatever you highlight or point with your mouse here in the elements tab, it will also be highlighted blue in the page. So if I put my cursor or my mouse over the body, right, you can see that everything is highlighted blue from top to bottom. It's not even showing up anymore. Why is that? It's not highlighting anymore. I think it's lagging. Yeah. So it's only up to here. That's weird. I think it's just hidden behind maybe something. I'm not pretty sure, but it should highlight everything because everything is under the body. See, and I think there's just something wrong here. Um, but yeah, as you can see, everything that we see here is under the body. After this is just Grammarly, the one that I installed. But let's continue. The same can be said for the reverse. So if you were to use something like this one. This is called the inspector button. You click this and then you point anything in your page, like for example, this one. You can also see that in the Elements tab, it's also switching, right? It's going to the line of code that is associated to whatever you're pointing at. So this is a good way to quickly look for the information that you're looking for. Let's say, for example, this one, you're looking for this table. So all you have to do is highlight something specific like this one, right? Then you can see that in the Elements tab, there's already a table. So this is what we're looking for example, right? On the right side, we have the styles, the computed, the layout, and the event listeners, which we really don't need right now. What's important is the HTML. So you can just move that aside here and make some bigger space. And then uh, yeah, we're gonna look for the data that we want. So if you keep on expanding this, right? So we haven't actually expanded everything. We've just expanded one div. Okay, if you expand everything, then the file size is gonna get so big. Well, not really the file size, but like the lines of code. Okay, you try maybe you were underestimating the number of lines needed for an HTML file, but it's actually a lot. Okay. So imagine this, right? And you were looking for the data that you want without an extractor, the help of an extractor, right? You can kind of see how difficult it would be, right? It would be very like inefficient use of your time and you know, it's a waste of time basically. So yeah, it's quite long and I haven't even expanded all of them yet. I forgot if there was a shortcut here to expand everything. Uh, collapse. Nope, nope. Right. I don't see the button that makes it expand everything. Um, but yeah. Let's see. Mm, right. So let's say, for example, we're looking for this one list of products. So as you can see, it's the inner HTML. The things that you see here, the words usually are inner HTML. Okay. So the images, of course, the images. What else? So in the sources tab, although well, not the sources tab, the network tab, although it's not very useful for us, it kind of gives you like perspective on what's happening. So if I reload a page, okay, so it loaded what? How many files? So there were 64 requests overall. It finished in 711 milliseconds. It loaded in 278 milliseconds, and then the actual load of the page is about half a second, right? So these metrics are important. Why? Because people nowadays have very low attention span. So if it shows up red, like this one, for example, um, it actually fails the standard. That means you either have to optimize your page or load less things that are taking up time to load. So yeah, there are 66 requests, and these are all the files that were downloaded in that time. So you have all the things like document, PNG, WebP, you have style sheets, scripts, all right? Because there are some instances in web scraping where you're looking for the things that were downloaded to the page. So there, it might be useful in a way in the future for you guys. So there's some SVGs, like the arrows that you see, those are SVGs as well. You can see the preview if you want something like this. See, you can see the preview. Um, the flags, there you go. Okay. So yeah, that's all that we'll have to learn for this um, part of the lesson. All right, let's go back here. Now, what we want to do is to scrape the web page, right? So we're gonna be accessing the page. We're gonna make requests, and then we're gonna feed it some Gitable soup. That's the basic um, goal that we have. So first is gonna go back here. Okay, we're gonna put it into a variable, our website. Okay, so here's our website. Next is we're gonna use the request um, library. So this is another one that we have to do. Fortunately, this comes in Python by default. So you can just say directly import request as RQ. So I'm going to name it RQ. So what does this do? This library makes our program pretend like it was actually a browser so that it can access websites. All right, I hope I'm making sense. This library makes our program act like it was a real browser, making it able to access websites and download resources. Resources that we have seen earlier here. So one of those resources, of course, is the HTML file. We need to download this thing. All right. So what do we need to do here? Um, page. Page is equals to RQ dot get. And then you're just going to pass the URL. And then you're going to get the text property because you just want the HTML file, right? In fact, if you print this one, we're going to see the HTML file. So it's going to turn black for maybe half a second and then turn white. That means it's still loading. Now you can see that this is the entire file for this is the entire HTML for that website. Okay. So at this point, it's not really collapsed, more like everything is expanded. Over here, when you viewed it, it's almost everything is collapsed, right? Here, everything is expanded. See, so it's quite long, really. Just for a very simple web page like this one, you might expect that, hey, there's only a few data there. It might not be too big. There might not be a lot of lines, but this is the reality of it. Okay. Now imagine you were looking for the data that you want here, and imagine you were looking for multiple pages of data, right? So you can just imagine the workload that you would have if you were not to do this automatically. So I hope um, you guys get the picture of what we're trying to do. Next, we're going to be using Beautiful Soup. So we're going to have to import Beautiful Soup here. So from BS4, import Beautiful Soup as yes. All right. Now we have the HTML file in text format already. So all we have to do is just feed it directly to mutable soup. So equals to ps page, and then just try to run it. If it has any error, and it doesn't have any error, so that's good. That means it's working. So right now we have accessed the site. We have downloaded the HTML file, and then we have passed it successfully to Visual Studio. So what next? Next is we're gonna have to look for the target data that we're trying to download. All right. So what are we trying to download? We're trying to download the top 10 countries with um, coffee production, right? So before we actually do the codes here, what you usually do is you explore the web page itself. Okay, you're gonna look for your target. So in this case, I'm guessing it should be this one. Uh, oh, well, all right. Okay. So F12 again, right? And then we're gonna use the inspect element. We're gonna look for the table. Okay. This is the caption. This is the table, right? So let's see. Do you think there's any other table outside of the one that we have here? So I don't think there are other things that can fit a table. Maybe this one, but it looks like it's not. So what we can do is we can just try it for now. Try it one by one. Okay, so we can see what we get. Okay, so we're gonna say table is equals to soup dot find and then table. Right, and then we're gonna print table. Let's see if what we get is correct. All right, so it says table border one class with the table sortable column two right. So it's this one, and then followed by major countries for green coffee production. So this is also what we get here, major countries. So I'm guessing we got it correct. Uh, the first table is the one that we're looking at, and then if there are any other tables after this, it doesn't matter because this is the one that it first saw. So that's okay. So that's good. We're done with that. Next is we need a variable to hold the data that we are trying to export or to extract. So we'll save it as the top 10, and then this will just be a regular list, something like this. Okay. Next is what do we do? We look for it, basically. So what can we do? The structure for this one is T head, right? T head. So the T head again is just the topmost part. So I'm guessing the T head is this one, country and production. So yes, country, and the other one is production. See? So I'm correct. So we don't actually need the T head. We can go directly to the T body, right? The first TR here is for Brazil. Brazil, here we go. Okay, but is this the first TR? No, because there's another TR in the T head. There's one TR in the T head. So we can say, we can loop over this by saying for row, right? In our table, mm, table dot find all, and then we're looking for all the TRs, okay? But we do know that we have to start not at the first index, but at index 1. So at the second element, we know that that is the start of the top 10 list. But instead of 0, we're going to say 0, a 1. and then the top 10, right? So plus 10, that's 11. So this is what we're trying to loop over to. Next is, um, so now we have access, right? So we can print each one supposed to be. Um, so let's say we have access to each row. What is inside each row? So inside each row, we have one PD. We have two PDs. And what do we need? There's a lot of spaces here. We can try and clean the data for now. So we can say temp dot row, no, temp is equals to row dot text. We're trying to access the text property. And then in order to clean the spaces and the new lines, we're gonna have to replace all those characters. So all those what slash ends. Okay. So right now we already know that there's already two slash ends at most in that line. So this is just a guess. So we're just basically guessing at this point, but from the looks of it, it really does have two ends slash ends. Well, backslash, right? Because we're trying to use the escape card. Okay. And then after replacing all of those parts where it says new line with a blank one, this one a blank, not a space, a blank, um, then we're gonna have to strip them out. Okay, so strip is it removes all the spaces at the beginning and at the end, and what you're left is just the whole sentence for all the text that you have. So if you were to print this out, what will you see? An error. All right. Row and table. All right, I forgot this one. All right, so it's looking much more cleaner now, right? So from that very big HTML file, we have isolated the thing that we want. So how many countries are there? One, two, three, four, five, six, seven, eight, nine, 10. Oh, all right. So there are 10. Mm, mm, mm. Let's see if the structure is the same. So most of them have the same structures, right? So it's TD span A, and then another TD for the amount. So TD span A, TD amount. So maybe we can use that one later as well as kind of an alternative way of accessing the data. Because what happens with this, right? If you're using text, but when you're using text, row.text, it basically gets all the text values for this entire row. Now, there is an advantage to that one, and there's also a disadvantage. The disadvantage is later when we encounter this one, Central African Republic. Why? Because it has spaces in between. So it's kind of like a special target because it's just one. All the others don't have spaces. So you're gonna have to create an exception for that. Um, so yeah, for now, let's just continue with this. So we say if we were to convert this one into a list, right? Let's convert this one to a list. So we have these two, we can split them up to separate them into words. So temp list, right? Temp list. And then we can say temp dot. As you can see, we're using a lot of almost everything that we have learned so far in Python, right? Like subscripts, the in, the for loop, methods, properties. So it's all coming together, right? So for temp dot split, okay, we're gonna convert it into a list. Why? Because we want to separate them, the country and the amount. All right. And after splitting it up, then we can place it now in the top 10. So we can say top 10. We can use the append method for lists, right? And then we can save it as a tuple if we want. So temp list of 0 and then temp list of 1. Uh, So now I can print the top 10. All right. So now it looks even neater, right? So we save it um in terms of tuples. Now this is the part where I said earlier that it's gonna have um not really an error, but a mistake. So it extracted just the two words Central African. So we need to modify this one in the end, just to get just to cater things that have multiple words in their um, country names. But for now, let's just try to remove that one. Okay, let's just make things easier for us for now. 1 to 10. So top 9, not top 10. So here we have it, top 10. And then after that, what can we do? Let's see. What did it do here? Oh yeah, it's doing the same thing. It's printing it. So it's using 0 and 2 because I'm not really sure why it's using 0 and 2. Probably because they're looking at a page that is older. We're looking at the page that is updated. So the values must be different. Okay, so that's why it has, by the time that this was made and this was updated, there's a difference. So yeah, I think only those two has changed. Everything else. Okay, this one as well. So they started at 2. We started at 1. We started at 1. Okay. And yeah, finally, the last part that we can do in our web scraping here. This is just for one page, by the way. So we're gonna do something else for a multiple web page. All right, so we're gonna need the library called Pygo for this. So we're gonna have to install another library. Okay, unshare, and then I'll go to Anaconda Navigator. Okay, so the same process as before. Um, you're gonna have to clear the search. You're gonna have to look for Pygal, Pygal, 1G only, 1G. And then this is what you will have, okay? So right now I don't actually have it. So I'm gonna click on the check here, the box. It will display a down arrow. So this is actually good so that the others can also see what it should look like. After that, you click on apply and this will come out, okay? We're gonna have to wait until it finishes getting the packages. And then, yeah, let's just wait. So hopefully it won't take too long. Hmm. How about you, RJ? Are you still installing or is it done on your end?
Still installing, sir.
All right.
Sorry. Oh, it's done now, sir.
Okay, so that's good. All right. So these are all the things that are modified and installed. So they need to modify these files and then they need to install these two files. So all you need to do is click on apply and then wait for it to finish installing. Do you have any questions so far, RJ?
Still installing, sir.
No, I mean, do you have any questions?
Ah, no, sir. No, sir.
No? All right. So actually, if you guys were using another IDE, like Visual Studio Code, for example, you would need to go through other steps in order to install something, and you would need to use the terminal for it and type out the commands to install those things. So it's kind of a hassle a little bit, doing things so manually. This is what makes Anaconda great because it does that automatically, like this one. So all you need to do is just choose the library and then apply. You don't really need to think um too deep into it, just click and install. So that's good. Um, Another thing is that you don't create environments. So that's usually the mistake made by beginners and other ADEs. They forgot to create environments for their Python projects. So environments are kind of like a closed, not really closed, but more like it separates itself from the Python that is installed globally. So in that way, if you have any changes, like uh, libraries that you're installing. It will only affect your project. It will not affect the one that's installed globally on your device. So yeah, that's just um, you know, tips and tricks since the installation is taking a while. And I think it's done. And it's happening. All right. So we're waiting for about 10 minutes already, I think, or 8 minutes. So hopefully it should be done by before five. At least we're gonna finish this one. If not, then we'll have to finish this one next time. All right. So mine is done. How about yours, RJ?
It's done, sir.
Okay. So let me go back to this one. All right. So what is Pygo? Pygo is a library for um creating charts, something like this one. All right. And this is one of the most famous or popular choices out there. If you want to learn more about Pygo, you can just search their website. So just search for Pygo and then go directly to their like pygo.org, and then you'll be taken directly to their documentation. Like if you want to learn about how to do pie charts, okay, there's a documentation here. You can just export on your own free time. So yeah, more things to learn, right? So that's good. Um, right. So right now we just want to make it work in using the most basic types of the bar chart. I'm going to be using that one. And we actually have it here. So first is we're going to have to import FIGO. So let's say import FIGO, right? And we're going to have to go to after the loops. So we have the data that we need. All we need to do is just plug it in to our chart and it should be able to display. So we're going to say bar chart is equal to, going to call Pygo. And then how do you get the bar chart from Pygo? It's very easy. You use the method called Pygo.bar. So bar. And then it only has one basic parameter, or at least the required one. You say height and then 400. All right. Next is let's see. Mm, we're gonna create a for loop here. So yeah, so for item in top 10, right? Then we're going to access each item and we're going to add it to the bar chart. So bar chart dot add. We're going to say item of 0. Okay. And then, mm, yeah, item 0 and then item 1. But item 1 is a string. It's not a number. So we have to convert it into a number. So int and then uh, item 1, but we're going to have to remove the commas. So replace commas with blanks. Yeah, that's it. So we're going to add it there. And then finally, in the end, um, we're going to use the display. So we can just copy this one here from before. This one. Okay. And then display HTML. The bar chart has a special function that makes the equivalent HTML file or code, and then we can pass it here. So we're gonna say bar chart dot render. So this will make it render and give us the code needed for HTML. And then just to be sure, we'll add is Unicode here and make it equal to true. And then that's it. And then we run it and then wait for it. And there we have our chart. So that's web scraping, guys. Okay, from the beginning up to the end, we um, go to the website, right? We analyze the data, our target, where our target is located, how we're going to access it, or how we're going to use our extractor library, the people will see, to navigate the HTML tree, locate the data that we want, and then modify the data to make it more readable and accessible, right? Then, using our um, library for making charts, just a basic setup like the height, and then just adding the data that it needed in order to create something like this, right? So visually, right, this is much better than looking at the list earlier with the values, right? It has no impact, but this way, right? If you were the owner of a company or the CEO, this would mean that, hey, this is our biggest competitor. So it's from Brazil. What is Brazil doing right that we are not doing? That's making them very profitable in terms of what's the product again? Coffee bean, green coffee production. So in this way, it can kind of like guide the direction of the choices that they will make. So this is the key point of what data science is used for. It's for uh, guiding the decisions, right? Okay, and then getting insights from it. That's the main point. Okay, so yeah, I guess we'll have to end it here for now. We'll discuss more next week. We'll return on this a little bit before proceeding to the next few slides, where we will explore how to scrape multiple web pages in one go. Okay, so yeah, any questions so far, RJ, before we end?
None, sir.
Okay, so with that, we're gonna end our lesson. I'm gonna upload the recording and the file later if I can, or if not, then it should be by tomorrow. Okay,
Okay,
so
sir.
that's it for today, RJ. Goodbye. Happy
Thank you,
weekend.
sir. Happy weekend too.
Welcome.